Here are the answers to 4.2.5. So you might want to check that you got it right, if for no other reason, so you can study it later. The correct answer for number one, 1.2 joules of potential energy. You do 1.2 joules of work, you create 1.2 joules of potential energy. If you did explain that we lifted it 1.2 joules off a table and we added it, then great. 2A is a trick question. If the pencil is on a table above the ground, then yes, it has potential energy. The rolling has nothing to do with it because we're interested in height when we're talking about potential energy. If you put some kind of explanation like that, then that's what I was looking for. If it's above the ground, has a height above the ground, then it has potential energy. 2B, rolling the pencil across the table, as long as it doesn't change the height. Now, most tables are not truly level. So if you did that, you might actually be changing the potential energy, but that's because you're changing the height of the pencil. Either it's rolling down the table or it's rolling up higher up on the table. So if the table's flat though, and it rolls, then you didn't change the height of the pencil. The potential energy is 0, unchanged. And number 3, what are some examples? This is for the chat. For the chat, what are some examples of machines that use potential energy? So a water tower supplies water pressure to houses because the water is actually above the ground. Example, yes, when you're at the top of the roller coaster would be one. What are some other machines that use potential energy? Type that in the chat. So you probably want to be specific on what you mean by that. But as a pilot, I would say absolutely. We talk about potential energy all the time as pilots. So for example, in the airplane I flew, if we had to shut down an engine, we were always wanting to be as high in the air as possible, which may not be a high for what you might be thinking, but for us, we wanted to be as high as possible so we could use our potential energy to create work so that we could either climb and get higher or go faster or land or do all kinds of stuff. So yes, we would use potential energy as an airplane all the time. Hitting a nail with a hammer. Okay, a hammer actually is a machine. It's called a simple machine, okay, where there's a force input, and but it increases the force supplied. A drill? No, not a drill. Well, it might use it if you're going down, but that's really actually not using potential energy. To an axe, if you're using gravity to help it embed in some piece of wood, that might be part of it. So an escalator is using work against potential energy. So yeah, a slide, absolutely. You are using potential energy to cause you to slide down. Yes, airdropping things. You jump out of an airplane or airdrop stuff out of an airplane, you were definitely using potential energy. How about, what was a good one? There was a good one last block. Oh, what was it? Anyway, toilets actually use potential energy. Actually, the older the toilet, the higher the basket or the reservoir of water is above the toilet. In modern plumbing, usually the reservoir is like right close to the actual toilet itself. But yeah, that's so that it has more energy to flow and flush things out. Basically, anything that uses gravity, we set it up high and then we use gravity to cause it to do something. That's potential energy being used. All righty. Good. Most of you got a response. Check the questions, no questions. Well, we're getting to that one. We're going to show the second half of the questions here. Okay, here are the math, the 7-step problem answers. Check your answers for the 7 steps. If you have a question, you can write it in the Pear Deck or you can write none. Quick note, this drives me nuts, but we have not changed our equation sheet since I've been teaching. at Steel Canyon. So in your equation sheet, it has UG equals MGH. This UG is supposed to be a modifier of U. It's the potential energy due to gravity. So earlier we used FG, which meant the force due to gravity. Okay, it's confusing because on your equation sheet that G is written really big and it looks like it might be part of the equation, but it is not U times G. That is not what it is. It is just telling you it's the potential energy due to gravity. Because you can have elastic potential energy, you can have chemical potential energy, and those are actually very different than height above the ground. We are only talking about potential energy. So I only use U because we only do the one kind of potential energy. In most engineering classes, you will only use the U because it's just assumed we're talking about gravitational potential energy. Alrighty. Let's take a look at questions. Number 5, you might have gotten a slightly different answer. 8.93 is probably what you got. Thank you for actually doing a common sense check. That is not possible unless they are a baby. So that actually means there was a mistake, but that is the correct answer, 8.93. Great question. How do we know when 9.8 is negative and when it's positive, and how do we deal with that? Great question. So it's like, is he going to answer it? Well, yes, I am, but in just a second. All right. So I'll tell you what, here's what I want to do is I actually want to work number 5 real briefly. I want to work number 5 and just show you how I would work it so that you can see my process, see the madness at work. So let's work through that real quick. All right, so when we do this, we're going to do our R2D2 guess. Brenda is about to do a high fall off a building. As soon as I hear something that's high above the ground, I don't care what we're doing, I automatically start thinking potential energy, okay? Even if we're doing a distance and acceleration problem, I'm still thinking potential energy in my mind, but that's what I'm thinking. She is 20 meters high, that is a height or a distance, and has a potential energy of 1,750 joules, so that is U. And what is Brenda's mass? So we would say mass. Height, mass. I've read and I've labeled, so now I'm going to draw the story. So my buildings always look like that, okay? And then I draw my little stick figure because she's about to jump off the building. And she is a height above the ground. The height is 20 meters, which means her potential energy up here at the top is 1,750 joules. And we are looking for her mass. So notice that I'm trying to label it close to where that quantity actually happens in the picture. So this problem mentions nothing about acceleration due to gravity, but as soon as you start doing things above the ground, you should know that you're going to be dealing with, or possibly be dealing with, little g, acceleration due to gravity, which is negative 9.8. If you don't see it here, you will have to see it later. So negative 9.8 meters per second squared. Why did I put it as negative? Because it's happening in the downward direction. Little g is always downward, so it's always negative. All right, givens. So I'm answering your negative question here in just a minute. So givens, now I'm just going to go ahead and relist my givens. This is usually where, if I forgot the little g, this is usually where I realize, oh, I forgot to put that. Okay, U, H is 20 meters. Because as soon as I know I got U, I already know the equation, U equals mgh. So that's one reason why I'm like, oh yeah, G, I need that. U, H, M, no, let's put G, it's a given, negative 9.8. Come on. This is hard to do with a mouse or trackpad. I don't have a mouse. It would be easier with a mouse. Okay. UGH. No, M. M equals question mark. So I've got my givens, I've got my unknown, and now I need to write the equation. So if I go and I look for my equation, what I'm going to find is, actually, I'm going to write it up here. Here, let's erase that so I have more room to show you my math equation. U, if you write it from the equation sheet, it is UG equals MGH. But once again, I personally leave that off. Okay, but either one would be acceptable. Given unknown equation, substitute. Okay, so U is 1,750, put it in parentheses. Any substitution, put it in parentheses. Mass is M. G is negative 9.8. Now, and this is 20. Okay, now I'm going to solve. So when I'm doing this, I like to show my steps. For some of you, that may seem like a lot of extra work, but it actually saves me hours. Because when I make a mistake, because we're actually going to make a mistake because of the negatives, it helps me go back and find where I made that mistake. So what I do first is I carry down and I do any math that I can do first before I do any algebra. So I'm going to go ahead and multiply 20 times 9.8. So it's going to be M times 20 times 9.8 is 196. That is actually a negative 196. And now it's clear what I need to do with my algebra. So I'm looking for M. So I'm going to divide both sides by 196. Negative 196, actually. According to our math so far. And then I plug it in my calculator and I'm going to get 8.928, which is actually 8.93 kilograms. Now, that should be negative, but our mass is never negative. So so when we solve, we should always do a common sense check. Mass has nothing to do with direction, and that's what a negative means. So that means somewhere up here, we missed a negative that's hiding in plain sight. And where that negative is the height is technically a negative height. Okay? Or and that would be if we're counting from up there and going down. If we set this as 0, then our height would be negative. It's actually negative. Okay? And the reason for that might be confusing. Okay? Now, the bottom line is, either way, at the end of the day, the mass should always be positive. So if the energy is negative, you got a negative divided by a negative, and it's a positive. If we decide that the height was negative, then this was a positive 196, positive 196, positive 196. Bottom line is the mass should always be positive. You can never have a negative mass, at least for this class. Now, because of that, most of our energy questions, we don't deal with the negative energy, okay? Because the direction of energy can be very confusing. Usually a negative means something is either getting colder, and a positive means something's getting hotter if we're talking about heat energy. Potential energy generally means something is positive above the ground. Okay, so if we say this is positive, we're assuming that this is the ground, the ground, the ground. However, if we said this was the ground, okay, and this was like the Grand Canyon, then we could say, oh, well, it's actually below the ground. This height that we're talking about is below the ground, and then our energy becomes negative. Wow, talk about confusing. So for this class, we're going to always assume our energy is positive, and so we actually tend to ignore the negatives when we're dealing with energy. That's going to come back to bite us in 2 weeks, me saying that, but if you're on a test and you have the right number, but there are 0 negative choices, choose the correct number for your answer choice, okay? This is why I also want you to show your work, because if you put the negatives in and you write the negative and I can see your work, then I might give you full credit. Except I just said math should never be negative, so you should go back and pick which one is which. Okay, so personally, based on the setup of this problem, here's how I would actually consider this. Okay, she is on a building which is above the ground, positive ground, so the energy has to be positive, which means the change in her height will actually wind up being a negative change in height. Bottom line is she'll have 1750 divided by 196 and you get 8.93. But that is the answer. All right. The negatives are confusing. Don't let them be. Okay? Just remember what they actually mean. Direction. What is happening? Okay? All right. Questions on this problem? Any questions? If you do have a question, you may need to come see me during tutorials. Let's move on to talk about our Rube Goldberg. All right, Rube Goldberg design part 2. So let's go take a look at that. This was actually assigned for today. So some of you've done it, some of you have not. That's okay. You click on it. This is part 2 that we had talked about last week. You've already watched the video. So now you're going to create a design of a Rube Goldberg machine, okay? What I'm looking for is your design. You do not have to build it, okay? So, but your design should make sense. So it shouldn't be just like a bowling ball rolls down the hill, and then the next thing is a book falls off the table. How? That's not connected, okay? So your steps should be connected. So see how the ball rolls down the hill, toilet paper knocked off the table, the toilet paper lands on a ruler. So see how these steps are connected. Your steps should be connected. The last step is pop a balloon, and then you're going to plan out what that might look like. So you're going to draw out a stick figure table or draw a hill, and my bowling ball is going to roll down the hill, and it's going to go to the table, and there's the toilet paper. It's going to knock the toilet paper off the table, and it's going to hit the catapult, which is going to send the person flying, the little doll flying. Okay. Notice my lovely stick figures. Okay. The doll goes flying. It lands in a basket. Okay. But then I can label this is step number 1, step number 2, step number 3. Okay. So that's what you need to do. Yes, some of you have already done this. So you just have to attach it to this, spell out your steps, and you are done. Okay? Very simple. Now, here's the addition that was not on last week's assignment. Here's what I really actually I want to see this part. Okay? You want to have fun and do the Rube Goldberg. I want you to do this part right here. Work is anytime a force acts over a distance. I want you to pick at least one step and tell me how is work acting in your Rube Goldberg machine. Okay? So in every instance of your Rube Goldberg, there is a force generally being applied. That's how one object transfers the action to another object, is by a force. So work actually has to be done in each step for it to actually work. Okay? So I want you to explain how is work being done. And then I also want you to tell me where is potential energy happening in your project. Because in general, most Rube Goldbergs have some form of potential energy at work in the machine. However, if it's rolling across a table, it's not using potential energy, but there is potential energy available. So that's the assignment. Now, some of you have been asking for extra credit. Well, here is your extra credit, optional. You can then take your design and you can make a video of it, of you explaining where the work and energy is in your project. If you want to actually build it in real life, I will give you some extra points for actually building it. However, that can be pretty difficult if you're building it in real life. So that might be too much of a challenge. But you might build 2 steps, first and last one, or the last 3 steps, okay? If you do choose to build it in real life, even just for fun, a hint, start with the last step first, because you don't want to be like that one video where the guy hits the golf ball and then at the end of his thing, it misses the target, okay? You can also, I believe it was actually in this class, someone shared this with me. You can use Algodo, which is a simulation thing that you can actually create it virtually and not actually build it in your house. Someone did that, made a video, and already given me that. But what I'm looking for extra credit is not the Rube Goldberg itself. I'm looking for your explanation of how is work and potential energy working in your Rube Goldberg. So if you build it, bonus. If you don't, great. Hold up your picture and go, this is my Rube Goldberg, and here's what's happening. Okay? Questions on this assignment? We'll have like a minute left. When is this due? So the actual design shouldn't take you too long. Coming up with the steps, because you're just writing it on paper, it's just for pretend, it shouldn't take you long. Now, if you're going to want to build it and do the extra credit, then when is that due? It's due before December 18th. Probably like December 17th. Okay. Oh, okay. Great step. Great question. So I would actually like you to spell out each step, like write it here. Then for your picture, all you have to do really is go number 1, number 2. Does that make sense? So in your picture, you can just label it 1, 2, 3. Because if you draw stick figures like me, I may not be able to interpret what did Mr. Franklin draw? I don't get it. Okay, so yeah, you need to write it. Okay. Answer that question in the Pear Deck. What is the difference between PE and work? And then do great work this week. Make sure that when you take the quiz, you are using your video notes, and be careful of those trick questions. Once you've got the Pear Deck answered, we are done for the day. I am turning it to student paste. Make sure that if you have not answered a question that you go back and fill in those answers. Otherwise, have a great weekend. Come visit me in tutorials if you need help with anything else.